Today, let's continue to play around with NSCollectionView. In the past few days, we have tried to use the flow layout and grid layout built in to the Coker framework announced in 2015. Today, we are going to take a look on creating our own custom layout. So first of all, why do we need that? The main reason may be due to the lack of support for the current flow layout and grid layout, and possibly you may want a really custom layout as well. Say you want your items showing as a circle or showing scattered. These are examples from Apple in the Coca slide collection project. You can go and take a look. For instance, we would want to implement a very simple collection view layout, which is a list that's likely to be used in any to-do kind app. So first of all, let's take a look on the collection view. So somehow it is not always working. I may need to open another tab in order to find the collection view so that it shows up on the right side, which is sometimes quite annoying. To change to custom layout, we first choose the layout here with the custom. It will ask you for the class of the layout. It is similar to setting the layout in program, like the one in the view controller that I'm using. You can set your layout programmatically, or you can set that layout in the storyboard. For the custom layout part, it really doesn't matter. But more importantly, we need to create a custom layout ourselves. So let's go and create one. I'll use a Coca class. This should be extending the NSCollectionView layout, and let me call it CollectionView list layout, for instance. Save it. So here we have our own custom layout class. I can use it in the storyboard. So go to the collection view again, and then set the class here. Now our collection view is using the custom layout. But of course, it's not that simple. We need to implement the layout with some attributes override and some function override. There are several things that are really important in here, which is the basically two things. One is we need to implement the collection view content size attribute, basically overriding it and telling the size of the whole collection view. Let's start with it. We will override it, the variable as collection view content size, which is NS size. We are overriding it, so we just type the attribute over there with the override keyword, and then we could type get. Then the value returned within this get closure would be the collection view content size. By the way, if you want to check what collection view content size means, it may not be that clear in the Apple documentation. So sometimes we just go to the header file and take a look. Say here, we take a look on the header file. We can scroll down to the collection view content size, which may be in the extension. And in this case, it is here. So it describes that this size will be the width and height of the collection view's content. It contains all the content, So if you have many items in it, it should be the size holding all the contents instead of just the visible rect. So I'm going to implement this since it contains all the items, so it depends on the number of items in it. And I will do a simple version here. Say I just have one section with some number of items provided by the data source method. So let's say I'm going to get the count from the collection view. So since we are inside the layout, it has the reference to the collection view already. This will be set by Coca framework when we bind this layout to our collection view. So we can use the method number of items in session as we only want the items, and assuming there is only one session in it. So I will be using the session 0 as the first session, which is also the only one session here. In case there is no item provided, I will just return an S0 size like this. Otherwise, I will need to calculate the size. So say we can take first the size as the collection view dot super view. Take a super views bands as the size. So size has two parts, the width and height. And what I really want is the width of the super view, and then I can set the height by calculating based on the number of items here. So size.height would equal to the item height. So I'm thinking maybe I need to set the item size here. So item height would be a CJ float, for example. CG float is always used in those controls in setting the origin and size. So I just use CG float. So here the height will be calculated based on the item height and times the can number. So say CG float, I'm going to cast the can into CG float. And at this point, because I check the can number should be returning an integer anyway, so I could just set the can here and unwrap it. And let's see, that's simple enough, and I will be returning this size here. If I'm going to run it now, let's take a look. So it now shows like this. It seems it's just like what's done before. Let me see. Go to View Controller. Because I didn't remove these codes yet, I am still setting it as grid layout, so it is overriding the setting in the storyboard and not really using my custom layout. So let's just comment them and run it again. All right, cool. Showing nothing. That's somehow cool because I didn't really set the height and width for each item, but as you can see, it is scrollable because the I have set the content size of the collection view, so it has a bigger area than was visible in the current window. So it is now scrollable. So what I need to do next is really to set the size for each item based on their index path. There are two steps in it. First, by using flow layout and implement a custom one, and I need to override a method called the layout attributes for elements in red. As you can see from the header file, this is the class to be implemented. This will be called by the flow layout and get the layout attributes. Layout attributes are used to set the layout of each item inside the collection view. And in fact, the red passing in will be the visible red, and I will need to use this, and depending on the number of items inside, to calculate the red for each index path. And that has an array of layout attributes, and tell collection view to lay out each item one by one. So basically I need to calculate the offset in it as well. There are two steps as I mentioned, so let's just get it started. So first of all, layout attributes for element in red, and I will need array of layout attribute. Basically, each object of layout attribute will be for each item in the index path. So just like the content size here, I will first get the count of the number of the items in the session. Number of items in session, and assuming only one session here. And I'm going to convert it into integer this time. And then create attributes array, an empty array. The attributes. Then I'm going to loop through all the items. So starting from 0 to -1. That means it's looping through count times. As array always start with 0, so be careful of using the array range. And then I'm going to set the index path. I'm creating the index path based on the index here, and also assuming only one section. I need this index path because I want to call the layout attributes for item at index path. So to create the layout attributes object for that particular index path, implying that particular item. So I do this to create a new object of layout attributes. Then I'm going to add this to the array. Lastly, to return it. Then I'm calling this method, but this method is not implemented in the super view, so I need to implement in our current class. As you can see here, this is suggested by the NSCollectionView framework, and we need to implement it to create the actual content of the layer attributes. So let's head towards it. Layout attributes for item index path. So basically, the function is called from here, and just like before, see how many items here. In this case, we want to check whether the count is 0. Because if we don't have any item in this collection view, we don't need to create an attribute at all. So I could check this. If it is 0, just return new. It is able to return new as the required class, the required function implementation returns an optional value. Then I'm going to calculate the fame of this particular index path. So let fame with the NSRect on the XY axis, XY point, and the width height. So to make it simpler, it will be X and Y to be 0 all the time. The width, we can grab it from the collection view content size. And get the width, because it is a list, and we will have just one item per row. So just get the widest as possible. And the height part, this would be the item height. So hold on, there is a problem here. As I mentioned before, this method will be used to calculate all the frames in all the frames for each item in this collection view. So if there are many items, each item's Y position should be an offset instead of 0. Otherwise, they will all just stack at the same location, and you will only see one item all the time. So we need to calculate this Y axis here, Y position here. So to do that, this would be the item height times the current index path per item. So if I am the first item, it will offset 0 because first item is 0. If it is the second one, this would become 1 and then times the height. So it offsets by the height and so forth. Alright, now we go back to the height part. The height here would be really just the height. Cool. So now we have the frame, and let's set it as item attributes using the NSCollectionView layout attributes. And this is for item with index path as the index path passing in. We'll set the item attribute of frame with the frame here, and then return the item attributes. Alright, so you see the flow. We set the elements in red and then use it to loop through all the items and set the layout attributes for each index path. Let's run. Okay, things coming up, and it can scroll as there are many items in it, and then each one, as you can see, it we set it to selected, able to select before. This is the first item showing with 100 height. We set it in the item height here. So say I could change the value to a smaller one. Run it again. So it becomes smaller. And the second item will have the offset just good enough, and so forth. But let's see, if I'm now adjusting the window size again, oh, that's something I always do, right? Because it is a Mac application. Resizing the window should be quite normal. And somehow, there's some strange behavior. Actually, not that strange. If you observe more clearly, now my window width is like this. And if I make it taller, you will see the new item comes up just the same width as this. Why? Because when that item is being laid out, it tries to calculate the layout attributes again, and it takes the width at that moment. So it's showing like this. In order to solve this problem, basically we want to invalidate the layout for the bounds change, basically the window bounds, and then ask CollectionView to requery all the layout attributes and calculate again. To do that, there is a simple method, override should invalid layout for bounds change, and then just return true all the time. So now, adjust the window, it will be recalculating the width for all the items again. So that's a simple implementation of a custom flow layout. There is a gist available on the internet. Thanks for that, in giving us a good example, and I will post it as with me in the GitHub project. Let's take a look on different behavior of our CollectionView tomorrow. See you.